Hello there, and welcome to yet another episode of the CAP Python series. My name is Simon, and in this episode, we are going to be continuing our discussion as we look at different data structures that are used in Python. So in our last episode, episode 10, we used that one of those data structures, which happen to be lists. So in this particular episode, we are going to be looking at dictionaries, and we shall also look at tuples in Python. I have not put tuples here, but in this video, we shall be looking at tuples also. So let's get started. So a dictionary is a data structure in Python that stores data in key value pairs. Keys are unique, while values can be of any data type and can repeat. Dictionaries are unordered, meaning the items are not stored in a specific order. So you look at these three statements here, and they'll give you a clear difference between lists and dictionaries. First of all, last time we looked at lists, and we saw that lists store data in an ordered way, in a way that is ordered. For example, let me try to define a list here. If we have a list called names, it will store, okay, that's how you define a list. This is how it will store its values. We shall have a first value as Simon, and then we shall have another value as John, we shall have another value as Dennis, and so on and so forth. So the way a list stores values, this first name here, Simon, is having the index 0. The next name, John, is having the index 1. The third name, Dennis, is having the index 2. So these items or these objects are stored in an ordered way. They are ordered from the first to the last. That is how a list stores values. It considers items being in a way that is ordered. So for the case of a dictionary, we're saying for it, the data are stored in key value pairs. You have a key and then a value assigned to that key. We shall see what a key means. And then we're saying keys are unique, while values can be of any data type and can repeat. So the values for a dictionary are similar to the items which are in a list. Like you can see here, I can have these names repeating. I can have even Simon again here, and it is okay. So even in dictionaries, we are saying, I'm going to define dictionaries in a few minutes. We are saying you are free to have values repeating so long as the keys remain unique. And then dictionaries are unordered, meaning the items are not stored in a specific order. So when we are creating dictionaries, we emphasize more the fact that we store values in keys and key value pairs. You have a key and then you assign a value to that key. We don't mind about the order, that this is at index 0, at index 1. That does not matter for this case. What matters is putting a key and a value. So how do you create dictionaries? This is the syntax for creating dictionaries. First of all, you have to give a name to your dictionary, use an assignment operator or the equals, and then you put this are these called curly brackets? I hope so. So use these curly brackets, one opening and the other one closing. Then in between here is where you put your key value pairs. As you can see here, key value, key value, key value. Technically what you do, you put your key here like this, you put a semicolon. Is this a colon? Yeah, you put a colon and then a value, then comma, another key, colon, its value, comma, the third key, colon, its value, and so on and so forth. So that's how you create dictionaries. So how are they different from lists? Like, why do we have to create dictionaries? Why don't we just stick to lists and we move on? So when you see here, we are storing names of different people. That is what we have used this list to do. But then a dictionary comes in when we need to store data for a specific person here. Let's say we want to store data about Simon. Like, we don't just want to store the name Simon and that is it. We want to store some attributes of Simon, some other attributes, or what we can call metadata, or data about data. We want to store some more data about Simon. And when you use this list, it won't be very efficient to do that. So that's where we try to use a dictionary. So let's create a dictionary to store data for Simon. We can call it um, student one. This dictionary is going to store data for student one. So the name of the dictionary is student one. When you look at our syntax here, we said you put a dictionary name. After that, you put assignment operator. Then after that, you put those curly brackets. So that's our dictionary. We have finished defining it or initializing it, although there is no data. So to put data, we said you put key and a value. You put a key and its value, a key and its value. Each key is separated from its value by a colon. Then this pair, a key and a value together, they form one element. Then key 2 and its value together, they form the second element. Then the third key with its value together, they form the third element, and so on and so forth. So here, this dictionary here has 3 elements. So each element, the elements are separated by a comma. You can see here, after here, we're having a comma, then we put the second element, then a comma, and so on and so forth. So we are going to use that same method to input data here. So since I'm storing data about Simon, so the first key will be name. I can call it name or first name, but let me just go with name. So that is the first key. So a key has to go with a value. And in between, we said between a key and a value is where we put a colon like that. Sorry, we put a colon. Then we have to put the value for the name. So the value for the name is Simon. So that element is done. We have put a key as name and its value as Simon. After that, we put a comma and put another element. Let's say we want to put the age. So the age is the key, put a colon, and then the value is now the value of age, which maybe is 39. So age is an integer. I hope someone won't put 39 between quotes. So that is another element done. Maybe I want to put the city where this person comes from. So I'll put here city is the key, colon, and then the value of city, maybe cab. Do I want to put another value or element? Maybe I want to put, what do I want to put? Year of study. So the year of study is 3. Yeah, that's that. We can go with that. So I've created my dictionary here. And you can see here, this is different from this. You can see the data stored here. A dictionary, it typically stores data which has some relationship. You can see all this data that is here has a certain relationship. And what's the relationship? It is data about a particular one person. Unlike this, whereby we're just storing names and that is it, here we are storing data which has some relationship in that it is uh, data of a specific person. So that is a dictionary for you. So when you try to store this data in this list, you can see that it doesn't bring out a clear picture of the data. Just imagine here we are having name here, and then here we are having Simon, and then here we are having age, then here we are having 39. When someone looks at such a list, it does not bring out the picture that this dictionary is trying to bring out here. So that's why we have dictionaries. So how do we access dictionary elements? Right, we have seen that we've created our elements there. But now, how do I access it? If you have a dictionary in your data and I want to access it, how do I access it? So will you come and say print, then student1. You say print student1. This will print for you all the data, the whole dictionary, the way it is. Okay, you can see it is there. So how about if I just want to print this person's name? So for that case, here you put square brackets. And the moment you put square brackets, I hope you can see the keys are being predicted here. So you just choose the key whose value you want to print. So if I want the name, I will choose name. And I save and run, it will print for me this student's name, like you see here. If I want to print the age, when I put quotes here, you can already see suggestions there. I just click enter and my age will be printed like you see there. So that's how you access the elements of a dictionary. Moving on, how do we add elements to a dictionary? Let's say we have created this dictionary, but we realize that there's something else we need to add to it. Maybe we want to add Simon's CGPA. So what we do, you write the dictionary's name. Oh, what's the dictionary's name? You write the dictionary's name like that. Then you use those square brackets. Then inside here, you put the key of the element which you want to add. The key of the element that I want to add is CGPA. So here I'll write CGPA like that. Then you come here, you assign it to a value. What's the value of CGPA? Now the value, you put it the other side after the assignment operator. So the value is, what's my CGPA? Is it something like 2.3? Yeah, maybe it is something like that. So that is the CGPA. Now, when I come here and I say print student1, you will see that this value of CGPA will be added at the end of this dictionary. So when I print, you can see we have CGPA added here. Likewise, we can even add something else. We can also add, what can we add this time around? Can we add weight? Okay, let's add something which is string this time. What can we add? Course. Okay, so my key is course and the value is BCS. When you save and run, you see we have BCS, the course included here with its value, BCS. So that's how we add elements to, or add items to a list. How do we modify? Modifying is more or less the same as adding. Let's say I want to modify. I've realized Simon lied. He is not BCS. Turns out he does BBA. So if I want to modify this value here, instead of BCS, I put BBA. I'll just come here and, okay, this is already created. I can't use the same thing. But now I want to modify the value for course from BCS to BBA. What you do, you just write the dictionary name like that. You put your square brackets. Then you put the key for the item or element which you want to change. I want to change course. What do I want to change it to? I want to change it to BBA. So when I save this, and run, you can see now, of course, we have BBA. So that's how we can modify or change elements of a dictionary. I can even change the name here. Let me change the name. Still, I'll say student one. Then what do I want to change? I want to change the name. What value do I want to give to it? I want to give it this. When I save and run, you can see now name, we have Simon Peter. So that is it with modifying items. Now, how do we remove items from a dictionary? To remove items from a dictionary, maybe I want to remove Simon's city here. This cab, city cab, I want to remove that item. What I'll do, I will write student1.pop. We use a method called pop. Then inside here, we put the key of the item which we want to delete or remove. So I want to remove city. So inside here, I'll put city. When I save and run, we no longer have city here. I hope you can see. City has been deleted or removed. I can even remove age. You see, people like hiding age. So let me also hide mine. Just say student.pop. Okay, but now this one will undo what we had. Let me just use something else, because city will come back if I proceed with that. So student1.pop. I want to also remove age. Okay. So age has been removed. You can see here. And that's how we remove items from a list. Then we can also just remove the last inserted key value pair. Instead of specifying what you want to remove, we can just say student.pop item. So when you use this function here, pop item, this one just removes the element which was inserted last. So the item which was inserted last here, you can see it is course with its value BBA. So when I run this, excuse me, this will be removed. So when I save and run, you can see it is normal. It has been removed. So that's that. If I keep running, it will keep removing each item until we no longer have anything. So let me remove it from there. All right, so that's how we remove items. So we can also loop through a dictionary. Looping through a dictionary means iterating over keys or the values or both. Okay, we are going to use a for loop for this case. So let's say I don't just want to print one item. I want to loop through the dictionary and print these elements one by one. So I'll say for key in student one. Then when I say print key, hope everyone can guess what this will print even before we have it. Yeah, your guess is as right as mine. It is printing all the keys that we have in that dictionary. It loops through the dictionary, finds all the keys, and returns them here. But now we also want to print the values, not only the keys. So what we do, shall put here value. Then we come here and say dot items. Then when we are printing, okay, can we have it in a structured way? Okay. Hey, what's the error? Okay, okay. Okay, let's first have it like this, then we shall modify after. When we run this, you're seeing name, Simon Peter, yeah, 3, CGPA 2.3, course BBA. Okay, let's use some string formatting to make this look a little bit nice. So, okay. Then I want to put here the key, then like that, and then the value. Uh, so it will be a little bit structured and looking good. Yeah, like you see, name that, yeah, that. So that's how you can look through a dictionary and then print all the elements in that dictionary. Okay, so when do you use a dictionary? You use a dictionary when you need quick lookups by unique key. For example, if you want to return the items by just using their keys, you will need a dictionary because you can see a list here. A list does not have um it does not have the keys. So if you just say name, it won't return for you this. But here in name, this is the key for this value, age, key for that, city, key for that. So if you're storing data whereby data has some keys and data is organized in a form of keys and values, you will need a dictionary to achieve that. Then when you are mapping attributes to objects, maybe you are defining user profiles, you're defining product information, there you clearly need a dictionary because product information, that is metadata or attributes of data. User profiles like what we have just described here, this is a profile for Simon. A list can't bring you out this profile. It is a dictionary which does that. Then when the relationship between data matters more than the order of elements, there you also need a dictionary. Like when you look at this data, its relationship matters more than its order. Because just imagine you had a let me convert this into a let me convert it into a list chap. Then you see how creepy it would look. I just have to turn this into that. Then I come here, I turn this into that. Then I come and remove this and replace them with commas. Okay, remove colons, replace them with commas. Remove colons, replace them with commas. Okay, then let me also change its name and it is now student 2. Student 2. Let me first get rid of this. So when you look at this, student 2 is a dictionary, is a list which is trying to have the same thing that we are having here. Now, when you look at this data in student 2, it is data about a specific person, but then it does not communicate well. If I want to access name, there is no structured way for accessing it. Because here, if I want to return, if I want to print item at index 1, I'll just say print student 2 item at index 1, and it will return for me name. And it will return for me name. Let me first comment out this. So, okay, when I save and run, hey, what happened? Okay, for statement 1 on line 1, an indented block after 4. An indented block after 4. Hey, what's that? Line 1, for statement on line 1. Okay. Uh, okay. I commented out this. Okay, yeah, it is now fine. It is printing Simon because that's what is at index 1. This is index 1. This is index 0. If I put 0, it will just return name. Like you see. So there is no structured way to access the specific data. Maybe you want to retrieve the person's age. There is no structured way to retrieve it from this list. But from our dictionary, if you want to return this person's age, you just say print student 1 and then age, and it will return for you this value. But here, if you print student 2, then you put the index of age, it can't return for you the value for age. If we put student 2, then inside here you put what's that index? 0, 1, 2, 3. You put index 3 for city. It won't return for you cab. I hope you're getting the point here. The point is that we would expect that if I put here the index for city, it will return for me the value for city, but it can't return it. But here in our dictionary, if you put here student 1, city, it will return for you the value for city. So I hope you get the clear picture here. If you're lost, please put a comment in our comment section or in the WhatsApp group for further clarification. But I just hope everyone is okay up to this level. Then when do you use a list? We use a list when we need to maintain a specific order of elements. Yeah, now for the case of lists is when the order matters and there is no much relationship between the elements you're trying to store. Like you can see for the first case here, we were just storing names of different people. There's no different relationships between these elements here that we need to maintain. But here, if you look at this, there's a relationship between all of these data elements. Like this element name is related to this element Simon, because if I print name, it will return this. Age, this is related to this. If I print this, it must return this. This is related to this. If I put this, it returns this. But that can't be achieved in this list here. So this just puts them in a way that is ordered, but does not bring out the relationship. That's why when you print item at index 0, it will just bring you name, like you saw here. It won't return for you Simon. Okay. Then when your data is homogeneous, e.g. a list of numbers, names, and order or indexing is important. So that is it with the dictionaries. Let's jump into another data structure. This time, this one is called tuple, a tuple or tuples. A tuple is a built-in data structure in Python that is used to store multiple items in a single variable. So tuples are similar to lists, but they are immutable, meaning their values cannot be changed once they are created. Tuples are defined by enclosing the elements in parentheses and separating them with a comma. So we are saying here that a tuple is more like a list, but the only difference is a tuple, the moment you input data or items, you are not allowed to change. You're not allowed to modify those elements. Like when you create it, that is it. You don't have to come back, add, modify, delete. No. That's the only difference between a tuple and a list. And then when you're creating a tuple, you use these parentheses instead of the square brackets like it is for the list. Okay, so let's get a practical example here. I'll get rid of all this for now. Okay, even this, I don't need it. So we have the list there of people. Let's add some few other people. Okay, let's have it the way it is like that. Okay, we can have it the way it is like that. When I save this, okay, let me print. Let me print name. Okay, to return for you that list of names there. Now this is a list. If I want to add items here, remember how we added items to a list? Does a legend remember? We use append, right? So I want to append in another name to this list. Maybe I want to add Anita. And I save and run. You see Anita is added to this list. So a list is giving us a chance to add. So I want to add some other name dot append. Then I want to add Ivan. Okay, on printing, even Ivan has been added. So that is a list for you. Now let's create a tuple. This tuple, let's call it name2. Name2 equals to, let's have the same values here. Copy. So we said the only difference when you're defining them is here we use parentheses. We do not use square brackets. So, okay, that's the physical difference between the two. So name2 is a tuple officially. And if I print this name2, should be able to return the tuple. Yeah, it is there. So you can see our tuple has been printed there. If I want accessing elements, it is the same thing. Okay, we shall reach there. We shall come back to this characteristic. You can access elements the same way like you do for lists. For example, if I want to access John, here I'll put those square brackets. John is at index 1. So when I put 1, I should be able to get John. And there you go. So accessing elements is similar to the way we access elements for lists. We can also do slicing. Slicing means accessing from a specific index to another specific index. Let's say I want to access Simon up to Dennis and then ignore Simon. Okay, this is another Simon also, but it is fine. So I want to ignore this. So what I'll do, I will use slicing. So the first Simon is at index 0. Okay. The first Simon is at index 0. Then I want to go up to Dennis. Dennis is at index 2. So here I'll put 3. Remember, when you're using slicing, this last index you put here, it does not reach there. It reaches this index minus 1. So I expect it to reach index 2. By print, there you go. You have Simon up to Dennis. That's slicing. Okay. Accessing element by index, printing the whole tuple. Okay, we've covered all this. Then there are some common tuple methods like count. So count returns the number of times a value appears in the tuple. For example, here we are having Simon appearing twice. So let's say we want to know that maybe we don't know. So this one is quite simple, but you might have data where the data is very large and you need to find out how many times maybe an item is appearing like 1,000 times and you can't count that. This is simple for you because you can just count here simply. But just imagine it's appearing 1,000 times. Will you go through the data counting? That's bad. But here, there is that method called count. So just say name2 dot. So I need to find out the specific item that I want to count how many times it is appearing. So here I will say name2 then dot count which item do I want to know how many times it is appearing. It is Simon. So save and run. And there you go. Simon is appearing 2 times. If I change and put John, yeah, it returns 1. So that's how count works. Just returns for you how many times an item is appearing. Then we have the index method, which returns the index of the first occurrence of a value in the tuple. Let's say I want to know when did the name Simon appear first. So that's when we use the index method. So here you just say name2 dot index. Then inside here you put the item whose index you want to determine, and that is it. It first appears at index 0. Okay. Then we have data tuple unpacking. Tuple unpacking simply means we are uh, unpacking in our traditional way. It is the opposite of packing. It means removing items maybe from a sack, maybe items from a bag, items from anything. You are unpacking, removing and putting them somewhere. Maybe your dad has come back with a lot of things in a polythene bag and you're unpacking. So you remove sugar, you put it in the container for sugar. You remove salt, you put in the container for salt. You remove tea, you put in the container for tea. You're unpacking, but as you're unpacking, you're putting those elements to containers where they are supposed to be. Remember in Python, we said variables are like containers. So likewise here, we are going to unpack a tuple. A tuple is having a collection of elements, just like your dad will bring a Kavera having a lot of things packed there together. These are the items now. We want to unpack them, but we don't want to lose them. As we unpack them, we want to store them somewhere. I hope you get this. Like you unpacked sugar, you put where it's supposed to be, like that. So likewise here we can do unpacking or unpacking this tuple. So what we do, we shall say uh, name1. Let me name it like that. Name1, name2, name3. Are they four? Name4. So then we assign it to name2. So this is the same thing like we are doing. In the Kavera, that came with sugar, there is salt, there is tea, what else? And there is flour. So this this is the container for flour, this is the container for sugar, this is the container for salt, this is the container for tea. And you are assigning all these, you say, as you're unpacking those elements, put each element where it is supposed to be. So maybe in the bag where dad brought these items, they are ordered in that the first element is sugar. So at index 1, you're having sugar. As it is removed, it will be put here. So here the whole picture is the variable you put here first will be assigned to a value which is at index 0 in your tuple. Then the second variable will be assigned to the second value or the value at index 1 and so on and so forth. So that's how these values will be assigned to these variables here. So when I save, and now I want to print, let me print name1. Okay. And there you go, you have Simon. So this tuple has been unpacked and the elements have been stored in these variables here. Let me print that tuple and I see whether I can still access those elements. Okay, it is this one here. Okay, we can still access them, but they are technically, we have accessed those elements and stored them in these specific variables here. Okay, that is unpacking. That is unpacking. So what are the key characteristics of tuples? Ordered, okay, they are ordered just like lists. They maintain the order of elements. Okay, so you access elements according to their positions in the tuple using the index. Then immutable. Once a tuple is created, its elements cannot be modified. You can't add, remove, or change elements. Let's try to change that and we see. Maybe we want to change name2 name2, we want to change element at index 2 to Levi. When you save this, there we go, we have an error, and it's saying type error. Tuple object does not support item assignment. So you cannot try to come in and change, modify, or do all those things we were doing for the case of lists. So that's what we mean by being immutable. You're not allowed to change anything once the tuple is created. So this makes tuples useful for data that should not change. So when you're writing your programs and then you have that some data that you want to remain there, the user just uses it, but does not have a chance to change it. There you will go with tuples. You won't have to use the lists. And this is so good when you're building programs that or softwares that you have some sensitive data that you don't want your users to tamper with and change. And so you'll find tuples very useful for those scenarios. Then heterogeneous data. Tuples can store elements of different data types, just like lists. So in a tuple, you can have a mixture of strings, floats, integers. So there is that independence to have all those data types mixed together. Then hashable. Because tuples are immutable, they can be used as keys in dictionaries or stored in sets, unlike lists which are mutable and cannot be used this way. So you can have a a tuple used in a dictionary. Let me create a simple dictionary here to bring out the picture that this point is trying to explain. Maybe you have a dictionary, and this dictionary just shows different points. Maybe you're doing math, you have some mathematical function that you want to represent, and you want to store the coordinates or points somewhere. So you would need a dictionary. But then that point, you won't have a traditional dictionary which is having a single key. You will have a key which is something like XY, and then so that is where you will need that's when you need a tuple. You see, whenever you have those parentheses, you're defining a tuple. So you will have X, comma, Y. So that is the key. And then colon, and then here now we can use a list because the values, you can change them for the case of a dictionary, but the keys, you can't change them. So maybe this was the coordinate 5, 8. So I hope you've gotten the clear picture here. The point was the tuples are hashable. Because they are immutable, they can be used as keys in dictionaries or stored in sets. So we have used a tuple here as a key for this value here, 5, 8. Why? Because it is immutable. You can't come back and change this. And this is also a property in dictionaries. You saw when we were modifying the dictionaries, we were only modifying the values. We were not modifying the keys. If you have defined the age, you won't come back and you want to change maybe spelling or give it a different key. No. Once you've created it, you don't change the keys. You only change the values. So because of that property, you can, if you have a dictionary like this storing coordinates, you will define your keys using tuples because you want to come back to change this. But then your values, um you can store them as a list because this now X is 5 and Y is 8, but you have a chance to change this later on, but this you can't change. I hope this is okay. Okay, so those are the key characteristics of tuples. Then why use tuples over lists? Have we discussed this? We use tuples over lists when we want to maintain immutability. We don't want data to be changed. When working with constant data, that should remain unchanged. Yeah. Whenever you're building systems and there's some data you want to remain unchanged, you will always go for the tuples over the lists. Then performance, tuples are generally faster than lists, especially for smaller data sets, since they are immutable and require less overhead. Then hashable, I've explained this concept. Okay, take home for today. You will create a tuple to store information about a book. So it will store title, author, publication year, price, and then so the Python program should unpack that tuple into individual variables. Then you will print each variable and then check how many times a specific element appears in the tuple using the count method. Here I gave you even what to use. That's very bad. Okay. Then you retrieve the index of a specific value using the index. Oh, why did I give you this? But then it is fine. So this must be very simple for everyone to come up with. Then you will also write a Python program that creates an empty dictionary to store names and phone numbers. So you first create a dictionary, but then when it is empty, then ask the user to enter 3 names and their corresponding phone numbers. So you will enter the phone number, the names and phone numbers from which are coming from the user. Then store the names as keys and phone numbers as values in the dictionary. Then print the entire phone book. Then ask the user to input a name and then display the corresponding phone number from the dictionary. So this will give you some kind of a challenge, and which is good, although it is also very simple, but you must be able to come up with it. It's not very tough. I believe in you guys. You are very talented Python devs as of now, and you'll be able to come up with those simple scripts. So, thank you for watching this video. Thank you for following up with our CAB Python series. We are winding up in a few episodes, and we shall be jumping into the CAB AI series, which are beginning next week. So, what I will tell you is just subscribe to our channel and follow us on X so that you don't miss a moment. Otherwise, that's it from me today. My name is Simon, and these are the CAB Python series.